Hello, welcome to the next video in the CryptoSecEd channel. I usually use this channel to talk about security or cryptography related topics, but instead I'm going to talk about a small utility I've written. It's not actually security or cryptography related, but I think it's interesting, a nice, useful feature, something I coded up myself for a very specific problem. So the issue I was having was I was working on a draft grant application with some collaborators. This is a company I was working with. They had provided some contributions, and that we had multiple editors. And I was reading through the draft, and I was under the impression that I thought I was reading the same thing multiple times in the document. It seemed like there were bits that were being repeated, whether this was one person had used the same text, copied and pasted in multiple times, or two different people from the company had taken the same text and pasted it in separately without the other knowing. I wasn't sure. This company was doing me a favor by collaborating with me, so I didn't want to push back and make any demands or insist that everything be only used once. But if there was repeated sections in the text, I wanted to find it and either take them out or rephrase them so they were all unique. If I was a reviewer looking at submission and I saw the same text repeated, that would lessen my opinion on the text. So I wrote this code. It's available on GitHub. It's called Repeated Strings, and it does just that. It finds any repeated text in a document that is at least as long as a argument you could provide. So the default is 50 characters. If there are 50 characters repeated in the document, that will flag them out. Let me just run this here so you can see that it works. Look at the help file. I need to specify the source, so we'll use the text document here. And it says 19% way through this text here is repeated. And if you look for, let's see, Festubum, any, and so on, that is, look for the SCBULUMA. Festubum ante. We can see the two sequences here are here and here. And we see the full length of the match there. You'll notice here there's no white space spacing or punctuation characters, and I'll get to that in a minute. If we try this on a random Wikipedia article, so let me find one that has a decent chunk of text. Here we go. Evil. I can put that in a second text file. If I try to run it again on the new one, it gets no responses, no long matches. If I reduce the minimum length to 10, there's quite a lot of matches. Let me try again with 20, and we've got these two matches. So this is matching 30% through and 40% through the document, and this is 44 and 68% as she confronts Shelby. And we can check here as she confronts, and she confronts, and she confronts Shelby, and she confronts Shelby. So it does work. It also works on Word documents. So I've got a Word document here. I can specify that as the source and specify that it's a .x file, and it works as well. So if you're looking to code this yourself, the temptation might be to take the simple approach. So if we have our document here and we've got ABC and then ABC occurs later on, the temptation might be to start at the first 3 letters, say we're only interested in matches of 3 lengths or longer, and then check the next 3 characters. Are those the same? If not, carry on to the next 3, next 3, next 3, and just basically scan through the whole document looking for matches with the first 3 characters. And you might go through the whole document and nothing matches these 3 characters. And so you might then shift that on by 1 character and look at characters 2, 3, and 4. And then check, is that the same as that? Is that the same as that? Is that the same as that? So on, all the way through. And eventually you'll start at these 3 characters here and then check, are these the same? Are these the same? Are these the same? And so on until you get here and you found a match, these 3 characters match. So you could do that, and you could find all matches of at least 3 eventually. The problem with that is that approach is order n squared. If n is the number of characters in the document, then the formula for how many tests you're going to have to do, it's going to be something involving a factor with n squared. So because you're not starting, once you get as far as here, you're not having to check these, they've already been compared with these, you're checking from here on. There's going to be, it's not going to be exactly n squared, it's going to be less than that, but in terms of the formula, the highest power would be n squared, and so if you've got millions of characters in your document, you're talking about millions and millions of checks. So that is not how my code works. I've taken a slightly different approach, and I've used a dictionary. So in Python, we've got a number of different data structures. We've got lists, we've got arrays, you've got sets, but dictionaries are interesting. They are combinations of keys and values. So we specify a key as an index, a way to look up the value associated with that key. And each key can only be associated with a single value. So what we do is we take our, let's say our text document starts with LMNOP, and lots more characters there, and somewhere later on there's an NOPQ, put in a Q there. And again, suppose we're only looking at 3 characters at a time. So I take these first 3 characters, LMN, and I add them to my dictionary. So I say, okay, we're adding a new entry into our dictionary. We're going to create a new key, LMN, and that's going to have the value 0. So that's letting us know that 0 characters through this document is the string LMN. And I can close the dictionary there. So that is the dictionary we're using. When we check the second, third, and fourth characters, MNO, and every time we start a new check here, we first of all check, is this key in the dictionary already? So we test, does MNO exist? It doesn't, and because it doesn't, we add it to the dictionary. So now we've got a new entry in the dictionary, MNO, and we specify the index it occurs in the document. So I'm going to give myself some room, specify the end of the dictionary down here so we can add more. So as you scan through the document, you keep on adding entries to the dictionary if they don't already exist. So we've got MNO, NOP, OPQ equal to 3, and so on. So each time you move forward 1 character, you keep on adding entries into the dictionary. Eventually you get to here, NOP, and this already exists in the dictionary. So when you try to check this key In Python, this function lets you very easily check for existing entries. So this tells you, haha, this string occurred earlier back in the document in position 2. So you know, okay, this is a repeated string. This string is now matching something earlier in the document. We don't necessarily know from this whether or not the string will match beyond this, so we would have to do some manually checking back. We're only recording 3 characters in this dictionary, so with a little check I could test, oh, does the next character from this match the next character from here? You might have PQR and PQS, in which case we've got a match at 4 but not at 5. And once we're done checking that, we then can carry on OPQ, PQS, and so on. We can keep on scanning through. So it doesn't just find one match, it'll find all matches up to however long they are. So the code is here. It's just a little over 100 lines, not very long. We can see what's happening here in the main function. We've got some arguments to handle. So we need a file to scan. We need a minimum length. It's set to 50 by default, but you can manually set it lower or higher. And we've got this additional argument here. You can parse a .doc file, rather docx, Microsoft Office Word document, rather than a text file. I've got some code here to handle the arguments. If it is a Word document, you need to handle it slightly differently than a text file. But with both files, we're doing this process of reading all the characters in from the text document and then stripping everything that's not A through Z, uppercase and lowercase. So when I was looking for matches, I didn't care if there was different spacing in the matches, if there was different punctuation characters. I just wanted text characters. If there's a match, I want to know about it, and I want to be able to rephrase it or delete as needed. Once we've got our text, then we basically scan through the document, and each time we advance, we are either adding a new entry into the dictionary if there is not a match, or if there is a match between something that's already in the dictionary, then we're finding out how long that match was, and that's this longest subroutine, and this just scans through each matches, see if there's further matches beyond that length that has been found, and if so, prints out the position, the offsets, and the position through. So because I'm stripping out many characters, white space, and punctuation, I can't give an exact offset of where it was in the original document, but by giving the percent, by giving the offsets gives you an idea. So even just looking at some text, you're probably going to be able to figure out where the spacing is, and you can search through the documents yourself. So that's the code. It's a quite handy tool. I've used it a few times. It's useful when looking at assignments. If you want to check if students are repeating themselves, plagiarizing their own text, which isn't necessarily something that's treated the same as plagiarism, but it certainly speaks to the quality of the writing. If anyone was interested in taking this and expanding it, there are some features I would like to have added in addition. Certainly if you could find a way to highlight any matches back in the original Word document, that would be great. That would be a nice thing to immediately show where the matches are. Maybe perhaps color code them, so if there are multiple matches, you can tell the differences. Maybe other file types as well might be useful to support. At the moment it only works for Word documents and text files. There's plenty of additional areas of work for this if someone wanted to expand on it, but as it is, it's still quite a useful utility. Okay, so that's my video on my repeated strings utility. Hope you found that interesting and useful. Next video, I expect to be back to cryptography and security topics.